Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about linked lists. Now, before we proceed, it's actually worthwhile to mention that we've covered 22 lectures in this series. Now, the first 22 lectures were in fact necessary to build solid foundations for this course. It is actually from this lecture do we actually start by studying the core topics of data structures. Now, the first data structure is what is referred to as a linked list. Now, a linked list contains a number of elements, right, where the first element points to the next one, which points to the next one, which points to the next one, up until it reaches the end. Now, because one element only points to the next one, you can traverse from the start, beginning from the start till the end. You can't actually go backwards. Now, applications of this particular kind of data structure could be, let's say, time itself. So if you're present at a particular instance of time, you can only move ahead. You can't move back, right? Now, to circumvent this particular caveat, there's another solution which is called a type of data structure, which is called a double linked list. Here, every node can point to the node next to it and the node previous to it. So the difference between a single linked list or a double linked list is that a single linked list can, or it's usually called just linked list, you can only traverse from the beginning till the end. But in a double linked list, you can traverse both up and down. Now, another option is what is referred to as a circular linked list. In a circular linked list, it's very much like a double linked list. It's just that it loops on its own. So anything, I guess you can here move both clockwise and anti-clockwise. Now, a very good applications for circular linked lists could be things which are periodic. So your timetable, for instance, right? You have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, which are just holidays, and then repeat, right? So, or the seasons of an year, right? So that is something which is periodic in nature, hence can be programmed using a circular linked list. Now, how do we program any single component? Now, any single component contains the node itself and something that can help you point to the next node, right? So let's make this a little more complicated, right? So let's say our node contains a name, marks, and CGPA. So every node, let's say, corresponds to a student. Now, we've seen previously that we can in fact program something like this using a structure. So a structure by the name of element can contain a string which is name, integer which are marks, and double which is a CGPA, right? So that kind of like solves the easy part. But the interesting part is how can we program something that points to the next element, right? Wait a minute. Something that points to, oh, you know what? How about using a pointer, right? So you can actually use a pointer. Now notice what happens here, right? So now you can actually have a pointer by the name of next, which is a pointer that can point to the next element. So now this arrow, which is indicative of a pointer, is no more outside this element structure, it's actually present inside. And this pointer is represented by this name next. So let's consider an example. Here we have name Bilal, marks 90, CGPA 4.5, and something that points to, well, right as of now, nothing. So here you have element A. Now you can access individual components of a structure using the dot operator. So A dot name has been assigned Bilal, A dot marks 90, A dot CGPA, and A dot next has been assigned null. So null is a reserved word which technically means nothing. So next is not really pointing to anything. So this is one way you can program a single component of a linked list. But there is more than just one way of doing something, right? So here I'm presenting another way of doing the same thing. So here is another component of the linked list. Here I'm accessing it indirectly. Here I was accessing it directly, so the whole structure is of the name A. But here I'm accessing the whole structure through a pointer B. So element pointer B. Now the name that B points to, this is just a dash and or a minus sign, a minus and a greater 2, which together become a pointer or our arrow. That's why we've been using arrow for a long time. So the name to which B points to has been assigned Imran. The marks that B points to has been assigned 95, and the CGPA that B points to has been assigned 4.7. And B, well, next that B points to has been assigned null. So now you can actually connect the two elements. So this structure A points to B and B points to null. The way you can do this is write A dot next has been assigned as B. You can do that because next is hence a pointer, and so is B. And then B's, the next pointer that B points to has been assigned null. So by doing this, you've actually connected multiple elements, and you can connect even more. And that's exactly our example of linked list. Okay, so that's how you can program a simple linked list. And you just witness it's not difficult at all. It's quite fairly easy. Using just structures and pointers, you'd realize that you would be able to do most of the data structures out there. Okay, so next lecture we're going to talk about some functions of the linked list, and we're going to add to our knowledge some additional functions by which you can use this data structure more fully. Okay, so up until next time, thank you very much. Bye bye.